Hello students, today we're going to look at the algebra of matrices. We've been using matrices so far to help us solve systems of equations. However, we can look at matrices on their own. Let's take a look at the definition of a matrix. An M by N matrix is a rectangular array of numbers with M rows and N columns. We can see an example here. There are M rows and N columns, and we have all sorts of entries inside, which we call A11, A12, A13, A21, A22, A23, etc. We basically name them based on the row and the column that they're in. We say the matrix has dimension M by N. The numbers A sub ij are the entries of the matrix. The subscript of the entry A sub ij indicates that it's in the ith row and the jth column. You'll notice that this definition doesn't mention anything about systems of equations. That's because matrices can be mathematical objects on their own. And today we're going to take a look at how they operate. We're going to look at when matrices are equal to each other. We're going to look at adding and subtracting them, multiplying them by a constant, a few other properties, and solving equations involving matrices. Let's jump in, and we'll talk about when two matrices are equal. Two matrices are equal if they have the same dimension and the corresponding entries are equal. So just to look at an example of two matrices that are equal, we've got one that has entries the square root of 4, 2 squared, e to the 0, 0.5, 1, and 1 minus 1. And this matrix is equal to the matrix that has entries 2, 4, 1, 1/10, 1, and 0. You'll notice that even though the entries are written differently, they're equal to each other, so these two matrices are equal to each other. However, if we compare a 3 by 2 matrix with entries 1, 2, 3, 4, 5, and 6, with a 2 by 3 matrix with entries 1, 2, 3, 4, 5, and 6, these are not equal to each other. They have different dimensions, 3 by 2 and 2 by 3, which automatically makes it so that they cannot be equal. We need the dimensions to be exactly the same, and we need corresponding entries to be equal to each other. Next up, let's look at adding and subtracting matrices. If two matrices have the same dimension, we can add or subtract them by adding or subtracting corresponding entries. Let's take a look at an example. Let's look at the matrix with entries 3, -1, 4, 0, 5, and 1/2. And let's add to that the matrix with the same dimensions and entries -3, 5, 2, -1, 3, and 1/2. When we're adding these 2 by 3 matrices, the result will also be a 2 by 3 matrix, and we get the 6 elements by adding corresponding elements of the other matrices. So we've got 3 plus -3 giving us 0. We've got -1 plus 5, which gives us 4. 4 plus 2 gives us 6. 0 plus -1 gives us -1. 5 plus 3 equals 8. And 1/2 plus 1/2 gives us 1. So this is how we add two matrices with the same dimensions. Notice that if they had different dimensions from each other, then we could not add them together. We can similarly subtract these matrices from each other by subtracting the corresponding entries, just like we added them in the last example. So again, we're going to get a resulting matrix that has dimensions 2 by 3. But now we've got 3 minus negative 3, which is the same as 3 plus 3, which is 6. We've got negative 1 minus 5, which gives us negative 6. We've got 4 minus 2, which gives us 2. 0 minus negative 1 is the same as 0 plus 1, which is 1. 5 minus 3 gives us 2. And then 1/2 minus 1/2 gives us 0. So these are examples of adding and subtracting two matrices together. We can, in some circumstances, multiply two matrices together, but that's more complicated, and that's something that we're going to look at in our next lesson. But for now, we can look at how we can multiply a matrix by a scalar constant, which just means a number. If we wanted to take the matrix with entries 3, -1, 4, 0, 5, and 1/2, and multiply it by 5, we can do this by distributing the 5 to each of the elements inside the matrix and multiplying them one at a time. So 5 times 3 is 15, 5 times -1 is -5, 5 times 4 is 20, 5 times 0 is 0, 5 times 5 is 25, and 5 times 1/2 is 5/2. So here we have seen how we can multiply a matrix by a constant and also add or subtract two matrices with the same dimensions. The last thing I want to discuss regarding matrices is a property of matrices. There are actually several of these in the textbook, but the one that I want to focus on is the commutative property of matrix addition. Let A and B be M by N matrices, meaning that the two of them have the same dimensions. If that's the case, then A plus B is equal to B plus A. What this means is that it doesn't matter the order in which we add two matrices. So long as they have the same dimensions, we should be able to add them in either order. For example, if we have the sum of the matrices with elements 1, 2, 3, 4, and also 5, 6, 7, 8, for example, we should get the same answer as if we added 5, 6, 7, 8 plus 1, 2, 3, 4. And I think you can see that this works clearly because in each of these, we end up with a 2 by 2 matrix for a result. And for the first entry, 1 plus 5 is the same as 5 plus 1. We end up getting 6 either way. And then 2 plus 6 is the same as 6 plus 2. We get 8 for the next entry. And the same is true for the entries in the second row. We get 10 and 12, no matter which way we do it. While it might seem like this is something that is obviously true, or at least something that you would expect to be true, it's important that we discuss it, because when we learn about multiplying two matrices in the next lesson, we'll see that it does matter which order we multiply them in, and we cannot change the order of multiplication and end up with the same answer.